So let's now move on to heat energy. In particular, relationship of heat with temperature change and phase change. Heat energy, variable capital Q, is energy associated with temperature change and phase change. Put simply, if you see the temperature of an object change, that means heat is involved. The same goes for phase change. The unit for heat is joule, capital J. You also have calorie, cal. And then you have British thermal unit, BTU. 1 calorie is 3.968 times 10 to the negative 3 power BTU, or 4.1868 joules. Note that there's also food calorie, capital C, AL yung unit. It's actually 1,000 calories, so please take note. When the temperature of an object changes, the phase is constant. When the phase changes, the temperature is constant. Note that no object possesses heat energy. Heat energy is energy in transition. It is always flowing from one object to another. Normally, heat flows from hot to cold, from an object of higher temperature to an object of lower temperature. As you can see in the figure, you have object 1, smiley face, and object 2, flower. The heat, capital Q, is flowing from object 1 to object 2, from temperature TH to temperature TC, where TH is greater than TC. Heat will flow from hot to cold until thermal equilibrium is reached. That is to say, objects will interact, heat will flow until all the objects have the same temperature, until thermal equilibrium is reached. When an object gains heat, the temperature increases. When it loses heat, the temperature decreases. Note that even though no object possesses heat energy, as we have mentioned earlier, we still use the term heat gain and heat loss, basically to denote the flow direction of heat. The heat will flow from one object to another. The first object is said to lose heat, whereas the second object is said to have gained heat. So heat gain and heat loss. And by convention, heat gain is positive and heat loss is negative. For temperature change, Q is equal to capital C delta T is equal to mc delta T, where m is mass of the object, capital C is property of the object, heat capacity of the object, unit is joules per Kelvin or joules per Celsius degree, and small c is property of the material comprising the object, specific heat of the material. The unit is joules per kilogram Kelvin or joules per kilogram Celsius degree. When heat is involved, whether heat is gained or lost, typically what happens is temperature changes. But this is not always the case. Under certain conditions, the object will instead undergo phase change. That is to say, solid will turn to liquid, or liquid will turn to gas, or gas will turn to liquid, or liquid will turn to solid. Phase change happens only under certain conditions. If these conditions are met, phase change will happen instead of temperature change. So let's take a look at these conditions. When a solid material is at its melting point temperature and it gains heat energy, the object will melt or transition from solid state to liquid state. On the reverse side, when a liquid material is at its freezing point temperature and it loses heat energy, the object will freeze or transition from liquid state to solid state. So solid to liquid transition and liquid to solid transition, the object must be at the right temperature and it must either lose heat or gain heat for the phase change for the transition to happen. For solid to liquid, liquid to solid transitions, heat Q is equal to plus minus mLF, where LF is property of the material, heat of fusion of the material. Unit is joules per kilogram. Similarly, for liquid to gas transition and vice versa, the object must be at the right temperature and the object must either gain heat or lose heat energy for the transition to happen. When a liquid is at its boiling point temperature, it gains it gains heat energy, the object will vaporize or transition from liquid state to gaseous state. When the gas is at its condensation point temperature and it loses heat energy, the object will condense or transition from gaseous state to liquid state. For liquid to gas, gas to liquid transitions, you have the following equation. Q is equal to plus minus mLV, where LV is property of the material just like LF, heat of vaporization of the material. The unit is joules per kilogram. For water, water being a common substance, please take note of the following. Please memorize the following values. It is recommended. The melting point and freezing point of water, melting point of ice, freezing point of liquid water are both equal to 0 degrees Celsius or 273.15 Kelvin. The boiling point of liquid water or the condensing point temperature of steam, gaseous water, is 100 degrees Celsius or 373.15 Kelvin. The heat of fusion of water is 333,000 joules per kilogram, whereas the heat of vaporization of water is 2,256,000 joule, 100,000 joules per kilogram. As you can see, the melting point and freezing point of water are the same. Boiling point of water and condensing point of water are equal. T melting is equal to T freezing, T boiling is equal to T condensing. This not only applies to water, but it also applies for most materials. So that's it for heat energy. We will continue our discussion in the next video, wherein we talk about the different modes by which heat is transferred.